This work is titled Investigating Opaque Infrastructure with the Desktop Odometer. My name is Jeremy Viny, and I'll be presenting on behalf of my fellow co-authors, Lucy Copper and Audrey Desjardins. When we started this work in autumn of 2018, one of the primary bridges connecting downtown Seattle to the greater metropolitan area was demolished. The replacement would not be finished for months. To avoid exacerbating the traffic congestion already present in the city, officials encouraged residents to work from home. Today, in a COVID-19 world, working or studying from home is fast becoming normalized, and many forego traveling to the office and instead connect using internet-enabled technologies like video chat and shared platforms. People use the web as a means of transportation. The challenge, however, is that web infrastructure is much more invisible than traditional transportation infrastructure like bridges and streets. This means that it is hard to know how it works, who maintains and pays for it, who profits from it, and how it impacts various communities. The Desktop Odometer is a device that shows users the distance they travel when browsing the web by tracking the total miles between their current location and the server from which they're requesting information. In making the Desktop Odometer, our goal was to create an artifact that would let people see part of the mechanics of the internet in real time. The Desktop Odometer allows users to observe aspects of the internet's elaborate and invisible infrastructure in relation to how they use it. Our work continues to build on this large corpus of work aiming at making internet infrastructure more visible. The entire production process took 12 weeks, in which we fabricated 46 desktop odometers. The making process consisted of 4 stages. There was low-fidelity prototyping, software development, high-fidelity prototyping, and batch production. To outline what this meant to the work going forward, we'll briefly go through this diagram. Our choice to actually fabricate a functional desktop odometer enabled us to do 2 things. We could use it and sell it. So then we were able to list the product on Amazon.com, and thus we were able to use Amazon to elicit user-generated content as well as research Amazon and other platforms from the point of view of the seller. When we started this work, we anticipated that most of our findings would emerge from customer reviews generated by selling a device on Amazon.com. However, the RTD process revealed unexpected barriers to entry within the platform infrastructure upon which connected devices rely, even before the object could reach users. During the process of creating the desktop odometer, we encountered logistical difficulties which revealed the opacity at many levels of internet infrastructure. That is, not only at the level of physical infrastructure, but opacity within the immaterial internet. We found such challenges interesting for the purpose of this research as they added dimensionality to our understanding of the complexity and multiple planes of web infrastructure. One of these barriers lay in publishing the browser extension necessary to use the device. In the initial design for the desktop odometer, we planned to make the browser extension available for free on the Google Play Store. However, the extension was repeatedly rejected by Google admins who cited a variety of issues. These issues included concerns about the use of non-proprietary software, a lack of a privacy policy, and the non-patented status of the device. To comply with these policies, we drafted a privacy policy, we rewrote the browser extension code, and despite these edits and 12 attempts to seek help from Google admin, the extension was never published. In each attempt to reach a solution, we were sent a boilerplate email listing the issues that we had already addressed. As a workaround solution, we offered our browser extension to customers on the first author's personal website, which required additional steps for the user to go through to install the device. We also wrote a detailed quick start guide to assist customers in setting up the device and browser extension. This solution required extra communication with our customers and may have made it more difficult for novice users to understand and even find our product. The desktop odometer was made less visible to consumers due to its absence from a prominent software marketplace, even if it was available on Amazon.com for retail. Of course, Google has these policies in place to protect their users from potential malicious IoT devices, and that impeding small IoT makers through these policies is likely an unintended consequence. However, we suspect that these policies still effectively block independent IoT makers from offering their devices on Google's platform. Because of the approval process and it being so opaque, Google offering little assistance to device makers attempting to comply with its policies, we are reminded of Sarah Ahmed's metaphor of a well-worn path in Living a Feminist Life, which she uses to explain how established models create barriers to non-normative ideas while strengthening the hold of the status quo. She writes, "When it is hard to proceed, when a path is harder to follow, you might be discouraged. You might try to find another route. A consciousness of the need to make more of an effort can be a disincentive. Just think of how we can be dissuaded by perpetual reminders of how hard something would be. Through the control of a dominant marketplace and the lack of independent seller support, Google passively maintains a particular path which may favor a narrow institutional model of smart devices, or at least heavily favor IoT makers with the resources to litigate such challenges." While the process of making the desktop odometer was important in building our understanding of Internet's vast infrastructure, one of our other goals with this project was to engage others in these reflections as well. In this work, we sought to encourage the users to think about how the internet works, and in particular, to consider the distance traveled by information as people surf the web. To deploy the device, we decided to use Amazon, though we could have instead chosen to list our product on a marketplace geared towards smaller artisanal goods like Etsy or more local audiences like Craigslist. We chose Amazon for a number of reasons. One, it is one of the largest online marketplaces in the world and has become a prominent platform to buy technology products such as IoT or personal computing. Two, Amazon helped shape the desktop odometer's identity as a product. Selling it on Amazon.com rather than on our personal website encouraged users to think of the desktop odometer as a real product, rather than a design project or speculative concept. And three, we wanted to inject design research and discussion about research into a setting where it could be seen by many, not just the HCI community. And finally, four, we thought it was funny, and there was some delightful irony in using Amazon as a place to sell something that was intended as a research artifact, creating tension between the values of knowledge production and those of capitalism. Amazon.com also carried the benefit of its status as a platform where people are accustomed to reflect upon and critique artifacts. Customer reviews are a genre of communication that are social, they're meant to be seen by others, and they're reactive. It's common for reviewers to use established formats to communicate ideas such as images of the product in use, unboxing videos, product comparisons, and more. This form of product feedback is thus a useful way to generate discourse around a particular object. While product reviews can be humorous and hyperbolic, or just plain incendiary, they are a useful communication tool users employ to articulate their experience with a device. Ultimately, we received 21 customer reviews on the desktop odometer, and for the purpose of time, we're unable to present the themes expressed in customer reviews, but we invite viewers to learn more about the reviews in our paper. Of course, viewing the distance traveled over the course of a web search can only give us a tiny glimpse into the complex, interconnected process that make up the internet. We see a fertile ground for further discursive design work to continue to create openings to reflect on the web. Our experience in researching and building the desktop odometer led us to consider different ways we could visualize web infrastructure. For example, what if we designed a device that not only showed distance in terms of numerical sum, but also traced the trajectory on a map, showing the routes information travels through? What kind of reaction would that generate for people? What if instead of showing where information travels, we put more emphasis on where data was stored? There is an almost infinite number of aspects of the web that could serve as a starting point for discourse around the ubiquity of opacity of the web. By prompting people to think more deeply about the internet infrastructure and processes and their relationship about the internet infrastructure and processes and their relationship to one's everyday life. We have hypothesized that people may develop a better understanding of those infrastructures. However, the question remains, can these design artifacts prompt anything beyond passive awareness? And as designers choose what parts of the web to make visible, what are they leaving unconsidered? How should one choose where to start revealing infrastructures of the web? Since these types of speculations are meant to be public, what are the implications of choosing certain dimensions over others? And with that, we would like to thank anyone and everyone for watching. We also would like to acknowledge and thank all the individuals who helped make this work possible. Thanks.